Hello and welcome back to AGT STEM. Today we're going to be watching a video about iridium. So without further ado, let's hop to it.
I've only ever seen before a 1 gram sample of iridium, which I bought myself for another video. And here I've got a big piece of iridium. This weighs 3.8 kilos. And iridium is the second densest metal that exists. Only osmium is denser, but the difference in density is so small that you wouldn't really tell the difference. It has one of the highest melting points as well, and I'm really impressed by this. It looks just like an ordinary piece of metal, but it's really quite heavy. I've got this sample because I'm at the Johnson Matthey Noble Metal plant, where they actually process this material. They take the sponge, which comes from the mines, where they dig up the rocks and process it, and turn it into metal objects. And this piece of rod is one of the intermediate stages. To get this bar, one has to process about 600,000 or 700,000 tons of rock. A huge amount of rock, nearly 1 million tons of rock, just to make this. Why should people want iridium? It's very useful because of its high melting point and its strength. Because of its high melting point, you can make it into crucibles. This is a very little crucible, but if you want to handle liquids at high temperature, 2000 degrees centigrade, you have no choice. You have to use an iridium crucible. So here is quite a small one. Might make quite a good vodka glass, actually. But the real crucibles that people use, say for growing crystals of silicon and so on, are really much bigger. This is
I wonder if iridium is expensive due to how much time it takes for them to process it and turn it into metal, and how much effort it costs. Because it's a really useful metal, which means they would need a lot of it, so it's a lot of effort for companies to process and make the metal into metal.
sheet of iridium for making a crucible. You make the crucible in 2 pieces. You have a smallish piece here that's the bottom. You cut out a circle, and then this piece is wrapped round to form the sides. This piece of metal, which is really very heavy again, will be rolled up and welded. And what's unusual about this sheet of metal, it's not very thick, but it's absolutely rigid. It doesn't bend at all. If you had a piece of steel like this, it would be beginning to feel slightly bendy. You can feel that it has unusual properties. It's not like a metal I felt before, and it's very heavy, and this density makes it very hard and rigid. But you can imagine how much this is worth, because the price of iridium is approaching £800 an ounce. So these are very expensive materials, and we're in a metal-free zone. We're not allowed to bring in any metal to make sure that nobody steals anything. If you don't have any metal, it makes it easy to screen you as you go out. You have nothing metallic, nothing that's an electrical conductor, so it's easy to screen. If you have lots of bits of metal, you might be able to sneak something through. So when I came here, everything went, my favorite pen, even my belt from my trousers. This is something I've never seen before. This is where somebody actually chooses the name of an element. So if you look down here, I should incline to call this metal iridium. So this is the first time that anybody ever wrote down the word iridium. Now, of course, he might have written it in his notes, but this is the first official record of anybody writing the word iridium. One of the other areas where you have very high temperatures are in the tips of spark plugs. You know, you put spark plugs into the tops of cylinders of petrol engines, and when the spark ignites the explosion, ignites the fuel-air mixture, then you get very high temperature, and you don't want it to erode away. You want the spark plug to work for thousands, if not hundreds of thousands of miles, and you do this by putting in a tiny iridium tip. These are the tips of the spark plugs like that. They're really tiny, and it's important to stress that modern technology depends on making these tiny, tiny components of iridium and getting them in the right place. So you use the metal you need at the really important point. In a spark plug, it's much less important what you make the nut from or the contact at this end, but you've got to get it really right just there, and then you get the maximum performance. I also like these here. These are the grains of iridium that are made from the sponge that comes from the mine, and the first stage of the processing is making these rather irregular sized grains, which can then be melted again and cast into ingots before they make bars like this. Earlier on, we were shown a whole tub full of grains of iridium, and I could actually run it through my hands, something I'll never do again, probably. But I really just want to pick this up again, make the most of it while I've got the time.
It's like your periodic videos mace.
Yeah, for once I can keep Brady in order. Iridium is found in very low concentrations on our planet, but it's found in quite high concentrations on asteroids and meteorites. And a physicist, Luis Alvarez, in the early 1980s, pointed out that there is a very thin layer, geological layer, in the so-called KT boundary in the rocks from 65 million years ago, which is rich in iridium. It has 100 times the concentration of iridium, and this is believed to come from the asteroid that hit the Earth and killed all the dinosaurs, because it vaporized and put a layer of iridium around the world. And by tracing this tiny layer of rock, which contains higher levels of iridium, the whole theory of how the dinosaurs disappeared from the world was developed.
It wasn't the iridium that killed the dinosaurs, though.
They were killed by the explosion, but it was the iridium that left the signature that let us understand what had happened.
That's super cool. Thank you so much for watching, and we'll see you next time. Stay smart. Bye.